On a grey morning in August 1942, inside Henschel und Sohn's Industrial Cathedral at Kassel, the first Panzerkampfwagen 6 Tiger rumbled off the line, its newly hardened tracks clanging like anvils on the concrete floor. To the soldiers watching, it was a monster made of steel and menace. Yet behind that moment stood an invisible campaign of ledger entries, rail schedules, and alloy recipes, every bit as dramatic as the roar of the 88mm cannon. The Tiger was not merely an armored fighting vehicle. It was the ultimate expression of German wartime logistics, an engineering miracle built in spite of strangled resources, aerial bombardment, and the gnawing desperation of a nation fighting on multiple fronts. This is the story of how thousands of parts became one fearsome whole. In the autumn of 1941, and after encountering the thick armor of British Matilda and Soviet T-34 tanks, Adolf Hitler demanded a heavy breakthrough vehicle that could dominate any battlefield. The Heereswaffenamt issued specifications for 60mm frontal armor, an 88mm main gun, and a combat weight under 60 tons. Competing designs from Porsche and Henschel raced from blueprint to prototype in a dizzying 96 days. Henschel's VK4501H ultimately triumphed, but the victory came with a daunting bill of materials, listing over 50,000 individual components. Every nut, bearing, and armor plate had to be planned months ahead, for without raw stock in the right depot at the right hour, the entire production schedule would freeze like a seized gearbox in Russian winter. Raw steel lay at the heart of the Tiger. Germany imported high-grade iron ore from Kiruna in neutral Sweden by Baltic freighter, then moved it south along the Reichsbahn to the Ruhr. There, at Vereinigte Stahlwerke and Krupp's Essen works, the ore was smelted in open hearth furnaces and alloyed with nickel from captured French stockpiles, manganese from Ukrainian mines, and vanadium scavenged from decommissioned locomotive parts. Molybdenum was so scarce that engineers rewrote metallurgical tables nightly, slimming the element to fractions while praying the plates would still resist a Soviet armor-piercing round. Even the 2-centimeter-thick belly armor consumed 1,500 kilograms of this precious brew. Every wagon load was guarded and weighed, for a single day's delay could ripple down the line and idle thousands of workers. Once cast into ingots, the steel slabs traveled by rail to Bochum, where massive rolling mills flattened them into armor sheets up to 100mm thick. Enormous hydraulic presses, groaning like prehistoric beasts, bent these plates into the Tiger's interlocking shell. Krupp's innovative single-piece mantlet required a 350-ton press stroke, and cooling the red-hot metal demanded 18,000 liters of water recycled through rooftop towers. Inspection teams tapped each plate with hammers, attuned to a specific ring. Any dull note meant microscopic cracks and immediate scrapping. Offcuts were swept into bins for reuse, nothing wasted. From there, finished armor traveled to Kassel on SSYMS heavy flat cars, their axles straining under loads approaching 80 tons. Parallel to the armor flow, the Tiger's beating heart took shape. The Maybach Motorenbau plant in Friedrichshafen machined the 12-cylinder HL 210 engine blocks from cast aluminum alloy, chosen despite shortages because it shaved precious kilograms. Each crankshaft traveled across Lake Constance by barge at night to avoid Allied reconnaissance, then by fast freight to Kassel. At the Rheinmetall Borsig factory in Düsseldorf, the 88mm KWK 36 barrel was deep drilled to a mirror finish, while Krupp's Grusenwerk in Magdeburg forged the breech and recoil mechanism. Precision ball bearings supplied clandestinely by Swedish firm Svenska Kullagerfabriken ensured the turret traverse stayed silky despite the gun's enormous mass. Even the track pins, small as a carpenter's chisel, required chromoly steel that Germany rationed like gold. Final assembly unfolded in Henschel's Werk 1, a mile-long hall whose concrete floor was stained by graphite, oil, and the scuffs of clogs worn by forced laborers from occupied Europe. A Tiger began life on Station 1 as a bare hull. Over 18 working days, it crept along 24 stations, hoisted by overhead cranes capable of lifting 60 tons. Power cables and wiring looms supplied by Siemens were threaded first, followed by hydraulic lines filled with synthetic Buna rubber fluid, produced at the vast IG Farben plant near Auschwitz. Turrets arrived on dedicated flat cars and were lowered into place with clearance measured in paper thickness. Inspectors tracked progress on slate boards, erasing and rewriting numbers as shortages forced sudden improvisations that would horrify any modern production planner. When a Tiger rolled out the factory gate, the logistical ballet continued. The vehicle's 56,900 kilogram bulk exceeded most road bridges, so nearly every tank left Kassel atop an SS Wms 16-axle rail wagon, secured by chains thicker than a man's wrist. Routes were plotted to avoid tunnels with insufficient clearance. At the railhead near the front, crews drained the engine's preservative oil, topped the fuel tanks with 1,200 liters of scarce high-octane gasoline, and torqued the track links to combat tension. Spare parts followed in dedicated cars called Nachschubwagen, each loaded with final drive gears, replacement air filters, and 38-kilogram armor-piercing shells. Without this rolling warehouse, a single broken torsion bar could immobilize an entire armored battalion. Allied bombers soon targeted the Tiger's nervous system. In October 1943, a Royal Air Force raid shattered the Kassel works, ripping open the assembly hall and melting machine tools into twisted ribbons. Production staggered but did not collapse. Henschel dispersed subassemblies to hidden sites. Turret rings were now machined in underground caverns near Sonneberg, engines assembled in converted salt mines at Marienschacht, and final inspection moved to a forest clearing camouflaged with canvas painted like farmland. Workers commuted through blacked-out woods, guided by rope lines. Material shipments traveled in night convoys under the Transportgemeinschaft Ostschild, their manifests mislabeled as agricultural equipment. Despite these heroics, monthly output never again exceeded 80 units, and by August 1944, shortages of fuel and tungsten doomed the Tiger's strategic relevance. Yet the Tiger's logistical legacy endured beyond its battlefield lifespan. Its interlocking armor pioneered welding techniques still taught today, and its component tracking system foreshadowed modern enterprise resource planning software. Long after the factory sirens fell silent, engineers from the United States Army studied captured production files, marveling at how a besieged economy had still mustered such precision under fire. Their reports seeded post-war doctrines on dispersed manufacture that would shape the world's automotive industry. Above all, the Tiger proved that even the most formidable weapon lives or dies by the hum of conveyor belts, the rattle of freight cars, and the ink lines on a dispatch clerk's clipboard. A single missing alloy, a bridge collapsed, or a night sky filled with bombers could halt the beast more effectively than any enemy shell. In the end, the Tiger was forged as much by accountants and railwaymen as by engineers and soldiers. For more World War II content, like and subscribe.